not going to be on the midterm. We're going to get it done, do the assignment, and just push it aside. Okay, so today we're going to deal with inverses. Okay, so basically, notation for an inverse is f to the negative first. I don't usually write that like that. I write it as f to the negative first of x. So that means f inverse of x. Okay, so all you do is switch the x's and y's. So if the point AB is on f of x, that means the point BA is on the inverse. Okay, let's go ahead and just go with example 1. Okay, here's a function right here, and they're asking you for the domain. Well, you guys, domain means what comes in. It's all of the x values. So we're going to make a brace, and we're going to list all of those x values right there that I just underlined. Okay, so they are 0, 1, 2, 3, and 4. Okay, the range is all of the y values, all of those second numbers, which are 0, 2, 4, 6, and 8. That's it. Okay, now let's find the inverse. So we're going to say that the inverse is, you're just going to take all those points, guys, and switch them. So the 0, 0 stays a 0, 0. The 1, 2 goes to a 2, 1. 2, 4 goes to 4, 2. 3, 6 goes to 6, 3. 4, 8 goes to 8, 4. And there's your inverse. Okay. Now they're asking us to find the domain and the range of the inverse. So here's how we note that. We say d to the negative first, and then a colon, and then range to the negative first. That means domain of the inverse and range of the inverse. Okay, so it's just as easy, guys. Look at your inverse. Look at the first numbers that are listed, and that's the domain of my inverse. So they are 0, 2, 4, 6, and 8. Okay, the range is all of the y values, which are 0, 1, 2, 3, and 4. Okay, tell me what you notice, everybody. What happens? They switch, right? Why do they switch? Well, domain is x, range is y, and if you switch the x's and y's, that's going to switch the domain and range. That makes sense, right? Okay, so here's something that you need to remember. Domain, range, domain to the negative first, range to the negative first. People forget this. These will always be completely identical. So the domain of the original function is going to always be exactly the same as the range of the inverse. The range of the original function is always going to be exactly the same as the domain of the inverse. Always. Okay? Some people forget that, and then it causes problems. Okay? Okay, so in order for something to have an inverse, it has to be 1 to 1. I'm going to keep it right there. It has to be 1 to 1. 1 to 1 means, let's write this down, no y values repeat. So in order for a function to have an inverse, y values cannot repeat, okay, which means it's 1 to 1. So look right here. In the original problem, do any of the y values repeat, you guys, yes or no? No. Talk to me, guys. No. So is it 1 to 1? Yes, it is. So now that I know it's 1 to 1, then I know I have an inverse, okay? All right, let's keep going. In order to decide that something is a function, okay, this is a little review for your midterm. In order to decide that something's a function, if they give you a graph, how do you decide if it's a function? What do? Vertical line test, okay? This is different. This one, we're trying to decide if these are 1 to 1, so we're going to do a horizontal line test, okay? So everybody look right here. I want you to draw a line, a horizontal line right here. Okay? Now, everybody in the room tell me, is that 1 to 1, yes or no? No. Okay, so everybody write no. Now, I want to explain why the answer is no. Everybody put a dot right there and label it 2, 4. Then over here is -2, 4. Those are the 2 points that I hit. Well, look at the y values, guys. They repeat. So if the y values repeat, then the answer is no. That's why it works, okay? Okay, draw a horizontal line right here, anywhere. Imagine grabbing that horizontal line, moving it up and moving it down. Will it ever hit the graph more than once? Talk to me. No. So is it one-to-one? Yes, it is. Okay, so very much like a function. Question C, they don't give you a graph. Okay, some of you need a little refresher on this from your quiz. End behavior. You look at the biggest exponent, which is a 4. That's even. So it's going to take the shape of a, talk to me, everybody, a parabola. Would that be a parabola that opens up, or would that be a parabola that opens down? It's going to be opens up. So it's going to be something like this. There's going to be waves in the middle, quite likely, but it's going to look like that. Then we're trying to find out if it's one-to-one. Draw a horizontal line right there. Everybody tell me what the answer is. No. Okay. Good. Okay. So if you have a true inverse, so this is kind of back to last time. You know how we did g of f of x and f of g of x? This is kind of tying this together. So if you have the original f of x and you do f of the inverse of x, you're always going to get x. And if you do the opposite, f inverse of f of x, you're also going to get x. Okay, that will always be true, and we're going to do that in just a second. Okay, true or false? If a graph has two x-intercepts, then it is not one-to-one. Let's draw a picture. Everybody draw an xy axis. Now give yourself two x-intercepts. So just go dot, dot, anywhere. Okay? Is that one-to-one? Everybody tell me. No. So let's read the question. If it has two x-intercepts, then it's not one-to-one. Is that true or is that false? That's true. It's not one-to-one. Okay? You guys, on your midterm, you will have true-false questions. You will have true fill-in-the-blank questions, and I don't think they're going to be very generous with partial credit. So you've really got to make sure those are right, because it's tough when you miss those, because you miss everything. Show work. Even if it says on there you don't have to show work, I would still show work on those true-false multiple choice. Okay, because even if you get it wrong, what if you miss the whole thing because of a stupid sign? You know what I mean? If you write it down and they can see that it's a sign, then maybe they'll show you mercy and give you something instead of taking off everything. So if I were you, I would absolutely show everything I could. Okay, show that these are inverses of each other. Okay, so here's what you do. You find f of g of x, and you find g of f of x. Now it says show that they're inverses. So if it says show, then I know that they are inverses. So if they're inverses, that when I do these, what are both of those things going to be equal to? Everybody tell me. They're both going to be x. So I'm going to do a little equals x and a little equals x right there, just to remind myself. Now, here's what happens. People know it's supposed to be equal to x, but they don't know how to do the algebra in there. So they'll write a bunch of stuff in there that doesn't make sense. And at the very end, they go, yay, I got an x. Okay, so you can't do that, because I really will look at all the details of what you put on there. Okay, here's another very important thing that you need to know on these things. Take one step at a time. And I'm going to show you exactly why you have to take one step at a time. Okay, here we go. So this is a review from last time. Find f of g of x. Take that g of x and replace it with what g of x is, which is 7x plus 4. Now I'm going to go into the 7x, which is right there. You guys listen. Write the f of x down. Write x minus 4 over 7. But that x is not supposed to be an x. So now we're going to take our erasers and we're going to get rid of it. And what are we going to put in place of x? Everybody talk to me. 7x plus 4. When I do that erasing thing, raise your hand if that makes it more, it's easier to understand, the erasing thing. Okay, couple. Okay, anyway, I'm just going to stop there. The difference quotient, f of x plus h minus f of x divided by h, you guys know what I'm talking about? It's a train wreck. We've got to clean that up. And I'm going to do the erasing thing to try to see if I can get this in your brain. So anyway, okay, everybody in the room tell me, can I cancel my 7s right now? Yes or no? No, I can't. But what can I do? My 4s, right? So then I have 7x over 7 when those 4s go away, and the 7s cancel, I get an x, and I'm good. Okay? Now everybody look right here for 2 seconds. This is why you can't do 2 steps in one. Watch this. Say a person was doing this, and they said, okay, well my 4s cancel, and then my 7s cancel, and I get an x. Well, that's great, but I don't know if you canceled the 7s first, which is not okay, and then the 4s, or the 4s, and then the 7s. I can't tell what you did first. So that's why you have to give me 1 step at a time. Okay, who says, I understand that? Raise your hand, let me see. Okay, good. Okay, this one right here. Find g of f of x, which is x minus 4 over 7. Okay, go into that g of x, which is right here, and wherever you see an x, you put in x minus 4 over 7. So you have 7 times x minus 4 over 7 plus 4. Okay, what am I going to ask you right now? Does anyone have any idea what I'm going to say? Can I cancel I want to say the wrong one first. So I'm going to say, can I cancel the 4s? And what's the answer? No. But what can I cancel? The 7s. So now I'm going to have x minus 4 plus 4. I took 1 step at a time. I got an x. And now I can see clearly that they are inverses of each other. Okay? Who says this is easy? I'm totally good. Raise your hand. Okay, good. All right. Here's what inverses look like. You're also going to have to graph inverses, you guys, okay? So check this out, okay? Here is your f of x. And I just got a paintbrush, and that's wet paint. Then I'm going to take my paper, and I'm going to fold it right here across that line, okay? That's the line of reflection. So when I fold my paper in half, where's it going to go? Where does the wet paint go? Well, this is going to go here. This close part goes here. This far away part goes here. This part goes here. They're going to hit at the same spot, so the pink goes right on to that, and then you've got your inverse. Who says, I'm with you? Raise your hand. Let me see. Okay, good. All right, so let's graph an inverse. Now, the way I do this, some people get a little confused. But I think if you can follow me, then I think it's going to actually end up easier. So if they're ever asking you to graph the function and the inverse, you guys, I always want you to draw that line of reflection. And that's always going to be the line of reflection. Okay. Now, here's the part that you might get confused on. I'm going to do this 2 different ways, and I know that's not typical, but I'm going to do it 2 different ways. Okay. So see this point right here? Where would it go when you folded it over? Well, look, it would go somewhere over here, right? Well, look at the distance. From that point to the line of reflection, I have a half of a diagonal. This being a diagonal, everybody look right here. This is a diagonal. So I'm half a diagonal away. So I'm going to continue in the same line and go half a diagonal away. So that's where that guy's going to go. Look at this guy. How far is he? Half a diagonal. Half a diagonal in the other direction goes right there. See this point where the red line hits my original function? My inverse is going to hit at exactly the same spot. So now I've got 3 points. Look at this point right here. It's half a diagonal. Go a half a diagonal in the other direction, and there it is. Now, all these little lines that I'm drawing, the half diagonal business, those really should not be there. I'm just kind of showing you what you should see. And now all you do is you just go back to elementary school now, and we're playing dot to dot. So look, you go dot to dot to dot, like that, and that's it. The graph is a little tweaked, but you get the idea. We're going to label it as f inverse of x, and we're done. Okay? Who says, I got that? I'm totally with you. Let me see. Do a big raise. Let me see. Okay, great. Here's another way you can do this. If you start getting freaked out, sometimes you get kind of confused. You know, it's like, where does that thing go? Watch how simple this other method is. See this point right here? It's left 2, down 1. That's negative 2, 1. See this point right here? Left 1, don't go up or down. This point right here is right 2, up 1. So that's for your f of x. So to find the points for the inverse, you guys, you just reverse them. So it'd be 1, negative 2, 0, negative 1, 1, 2. So positive 1. Okay, let me see what I'm doing. Negative 2, negative 1. I messed up on that. So this is negative 1, negative 2. So I go left 1, down 2. That's that point. 0, negative 1 is right there. Positive 1, positive 2 is there. Dot to dots, and I've got it. So 2 methods. Who says got it? You good? Okay. So use that second method if you get confused. Okay. All right. Now we're going to start finding them. Okay. Here's how you find an inverse. You guys, I know I keep kind of going back to the quiz. The critical numbers problems were lots of people missed them. You know why you missed them? What did I say? What's the reason people miss them?
Forgetting the steps.
They don't know the steps. That's exactly what happened. So what made me think of this is look at these steps. Just follow these steps, okay? Put a y in your f of x, switch your x and y, solve for y, and then go. So all you have to do is switch your x's and y's, guys, and solve. That's all you have to do, basically, okay? Okay, let's go ahead and do this. Question number 7. Okay, so here's the order I do. Here's what I do. I'm going to go up a little bit. I'm going to show you the order that I do this in, which I think is a great order for you to do it in. Okay, first thing is I write the equation. Y equals 2x minus 4. Everybody tell me what that looks like. Talk to me. It's a line. Okay, so the y-intercept is negative 4. So everybody go down 4 and make a dot. Then the slope is 2 over 1. So from that dot you go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Okay, I'm going to do lots of dots because I want my line to be super accurate. I'm going to draw it like that. Bless you. Arrows at both ends, and I'm going to be very clear, and I'm going to label it f of x. Okay, first thing I did is graph it. Now I'm going to find the domain and range of that graph. Everybody look at the graph and tell me what the domain is. Can you tell? It's everything, right? All x's, positive and negative, are going to hit it. So the domain is all real numbers. What's the range of that graph? Can you tell me? Also all real numbers. Okay, check this out. The domain of the function is all real numbers. Therefore, the range of the inverse is also all real numbers. The range of the function is all real numbers. Therefore, the domain of the inverse is also all real numbers. Would I really put those things right there? No. But I'm just trying to show you. Okay. Now I'm going to graph the inverse. Try to keep track of the order I'm doing these in. Okay. Now I'm going to graph the inverse. So I want you to draw that line, y equals x. Okay, looks like that. Now, look at all the things I know about my inverse. First of all, I know all 3 of those things are going to hit at the same spot. Okay, check this out. Half diagonal, point there. This is a full diagonal, point there. This is a diagonal and a half, point there. I could really probably stop. I'm just going to be a little more accurate. This is 2 full diagonals, 2 full diagonals. I've got enough. So now I'm just going to play dot to dots. Looks like that. Draw your arrows and label it as your inverse. Okay, bless you. I'm almost done. What I haven't done is I haven't come up with the equation for that green line. You can't just look at the graph and do it. They want the work for it. Okay, so watch what you do. Instead of y equals, we're going to go x equals. Instead of 2x, we're going to 2y minus 4. Now you just solve it for y. So the 4 comes over to the other side. So you have 2y equals x plus 4. divide by 2, and you get y equals, now I'm going to divide separately by 2. So I'm going to write this as x over 2 plus 4 over 2 is a 2. Okay? One thing is you'll lose points for. The other one is just awkward. Two things we need to change. See how that says y equals? It's the inverse that we're reporting. So you would lose points if you didn't write that. Okay? This is awkward. Instead of writing that as x over 2, what's a better way to write that? Yeah, push that 2 forward. Yeah, but it's on the bottom. So it's 1/2 x plus 2, and that's your inverse, and you got it. Okay, everybody good? Everybody good, guys? Yeah? Okay, let's keep going. Okay, there's question 8. Let's try to remember the order. Now I'm going to start asking you what's the first thing I did, what's the second thing I did, so then you guys can remember the order. Okay, so my original problem is y equals the square root of x plus 2. Everybody that remembers, tell me what's the first thing I did. I graphed it. Okay, so this is a square root graph shifted where, everybody? Left 2. Do you remember the stretch for a square root? Where do I go from there? Yep, right one, up one. Then go back, and then where? Right 4, up 2. Not 2, 4, it's 4, 2. Okay, so it curves in, and it looks like that. Now let's label it f of x. Do you remember what we did next? Domain and range, right? Look at that graph. What's the smallest x value that's going to touch my graph? Everybody tell me. -2 on. Okay, it doesn't matter if we do interval or inequality. Let's just do interval. We'll go back and forth. So this would be -2 to infinity. Range is y. Here I am down at the bottom. Tell me the smallest y that's going to touch my graph. A 0. And it touches it. So it's going to be 0 to infinity. Guys, these inverses will never be different. They're always going to match. So I don't even have to think about it. This is -2 to infinity. So this guy's -2 to infinity. This guy's 0 to infinity. So this guy's 0 to infinity. Done. What did I do next? Do you remember? You graphed it, right? So let's graph that in line of reflection. Always graph the line of reflection. Now let's graph the inverse. So full diagonal, full diagonal, full diagonal, full diagonal, hits all in one spot, draw it in, and it looks like that. Okay, label it the inverse. What's the last thing I need to do? Equation. Yep. So you're going to have x equals the square root of y plus 2. My y is trapped, and I'm trying to solve for y. So what do I have to do to get it free? Square. So you have y plus 2 equals x squared. Then the 2 comes over, and I'm going to be done. But instead of writing it as y, I'm going to write it as the inverse. So it's x squared minus 2. What if someone in your group said this to you? I'm totally confused because this is a parabola and my inverse is not a parabola. So I obviously did something wrong. Why is my inverse not looking like a parabola? Tell me. Yeah, the domain of the inverse is only supposed to be from 0 to infinity. So it's kind of like a piecewise function. You've got that parabola shifted down 2, but we're only graphing it from 0 to infinity. Who says, I understand that? Let me see. Great. Okay, let's keep going. 9. Okay, step 1. Everybody talk to me about step 1. What do I do? Graph it. Y equals x to the third plus 1. You guys know what a cubic looks like. The plus 1 takes my cubic and shifts it where, everybody? Up 1. So it's right here. Then a cubic is right 1 up 1, left 1 down 1, right 2 up. Do you know what that is? 8. Yes. It's 1 off your grid. And then this one is the last possible point on your grid. Just trying to help you not have to count. So I'm going to curve that in, and I'm going to label it f of x. What do I do now? Everybody tell me. Domain and range. Everybody shout out, what's the domain of that graph? Everything. What's the range of that graph? Everything. Reverse them. Everything, everything. Tell me what to do now. The graph. Yep. Draw that line of reflection. Now this one might be tricky. This one might be one, no, I don't think it is, where you want to reverse the points, but whatever you're comfortable with. So this goes here, they all hit here, this goes here, this goes here. This guy right here is 1, 2.5 diagonal, so he's going to come right there, and my graph is going to look about like this, curve it up, and go this way. Really steep like that. Okay, a little more of a curve right there instead of straight. Label it f inverse of x. Now come up with the equation. Okay, x equals y to the third plus 1. Solve it for y. The 1 comes over. So it's y to the third equals x minus 1. What do I do to get that y alone? Cube root. So I'm going to say f inverse of x equals, if it's cubed root, do I have to do plus or minus? No. So it's the cube root of x minus 1, and that's it. Why don't I have to do plus or minus? Because it's not an even. Yes, sir?
Would the negative 1 be inside the cube root?
Yes. Because you moved it over and then cubed root. You can't go like this. You could never go cube root, cube root, cube. You know what I mean? It's all left and all the right. Okay? Okay, let's do 10. Is 10 our last one? Okay. Okay, here we go. Y equals, everybody write down, y equals x to the second minus 3. That's a parabola shifted down 3. So everybody go down 3, make a dot. Normal stretch on a parabola, right one up one, left one up one, right 2 up 4, left 2 up 4, and there's your parabola. Everybody stop. I'm looking for an inverse. I have a problem. Can anybody tell me the problem? It's not 1-to-1. Bam. It's not 1-to-1. So that's why they're telling us to just take the positive x's. They only want 0 and bigger. So what they're saying is, don't count that part. Restrict that domain. Now it's 1-to-1, and now I'm going to have an inverse. Okay, let's draw that thing a little bit longer. You guys talk to me about this. So on a parabola, you go 1, 1, 2, 4, and then you go 3. What's the next one going to be? It's 9. 3 squared is 9. Yeah, so it's going to be right 3, 4, 5, 6, 7, 8. 1 off my grid. It's going to be right here. You're going to want to draw it really long because with that line of reflection, it's going to get a little, you know, we just want it long. So put f of x. Okay, everybody talk to me about domain. Domain is x. Start at the end. Watch my hand go. What's the smallest x that touches it? A 0. Let's write it as an inequality this time. Let's say x is greater than or equal to 0. Let's talk about the y's. Start low. Start moving up. What's the smallest y that hits it? -3. So we're going to say y is greater than or equal to -3. Reverse them. So the domain is y is greater than or equal to -3. The range is x is greater than or equal to 0. I went like this. I went like that.
Except you wrote y and x wrong.
Good. Good. I did it on purpose. Common error. Common error. So I switched those, but when you write them in inequality form, you have to switch the variable. So awesome, bud. So domain is always x and range is always y. Besides that, it's correct. Okay? Okay, here we go. Draw your line of reflection. Okay? They're all 3 going to hit at the same spot. half diagonal, diagonal and a half, diagonal and a half, another diagonal and a half, diagonal and a half, goes like this, curves in, got it. Label it F inverse of x. Now find it. So now we have x equals y to the second minus 3. What do I do? Tell me what to do. Move your 3. Y to the second equals x plus 3. What do I do now? Square root. Y equals, but I'm not going to put y, I'm going to put F inverse of x equals. What comes right after the equal sign? Plus or minus the square root of x plus 3. There's something wrong. What's wrong? It's the plus or minus. What's wrong with the plus or minus? You know, there's a couple of different ways to think about it. If you had this, a negative in front of the square root, that would take your square root graph, which looks like this, and it would reflect it across the talk to me. X or Y. You better spit that out fast. I mean, that better be second nature. Is this a reflection across X or Y? It's X. So your graph would look like that. Does my inverse graph, which is red, look like that? No. So I know it's not the plus or minus. That's one way to think about it. The other way to think about it is I know that the range of my inverse has to be the top part of that thing. So it's going to go up. Okay? Okay, let's do 11. And then we're done. Are we done? Okay, good. I want to get going on those corrections in case you can't tell. Okay, here's your f of x. State the domain of f and find its range using the inverse. Okay, so this is what they want, just in case you're confused. They want to know the inverse. They want them to know the domain of the original problem and the range of the original problem. You guys, we've never gotten range off of an equation. We always get range off of a graph. Okay, so watch what we're going to do. The easiest of those three things that I'm looking for, I can get it immediately. What is it that's so easy? The domain, right? So what two things do you check for when you're looking for domain? Even root, fraction with an x on the bottom. Take the bottom, x cannot be equal to a -1, so I've got one of them. Now, I don't know what the range is, so I'm going to skip over that for a second. Now I'm going to switch my x's and y's, and I'm going to solve for y. Now this is kind of hard. Okay, so everybody watch. Look at what I have right there. Tell me what I need to do. Can you see it? You should look at it and go, I can see it. Watch. As soon as I do this, hopefully more people will see it. What am I going to do? Cross multiply. Okay, so distribute the x. And you have xy plus x equals 2y. Okay, if I was solving for y and I ended up with, like, just don't write this down, but what if I did this? Xy equals 2y minus x. Get rid of that x, so I get y equals 2y minus x over x. Does that make sense? No, because I've got solved for y, but over here is another y. Y is equal to y. No, you can't do that like that. So that's not what you do. Okay, so look what I've got. This is the hard part. It will cause you fits for a while, and then after a while, hopefully it's going to click. I have to get those the y alone. Y equals. Anybody have any idea what we could do? Someone said factor. Go ahead, try, Tony. Take out the x. No, but you're so close, and somebody else said factor, so you're like this close, and the factoring we're going to do in a second. What am I trying to isolate? Tell me that. The y's. Okay, I'm trying to solve for y. So let's get everything that has a y on one side, everything that doesn't have a y on the other side. Okay, so let's write this as xy minus 2y equals, the x comes over and becomes a negative. Now everything that has a y is on one side, everything that doesn't is on the other. Tony, do you know what to do now? What do you think? You were so close.
Isolate the y.
You're going to tell us, don't use isolate. Say it in an easier way so they'll get it.
Oh, take out the y.
Take out a y. So if I take out a y, what am I left now? I'm left with x minus 2 equals negative x. I want the y to be alone. This x minus 2 is multiplied. How do I get rid of the x minus 2? Divide. So it's just going to be y equals negative x over x minus 2. I just divided both sides by x minus 2. Who says I got that? Let me see. We're going to do that again. You will see that again. So y's on one side, non-y's on the other. Take out a y and divide by what's multiplied by it to get rid of that. And there you go. Okay. Now, so here's my inverse. Negative x over x minus 2. Can anybody tell me how to find the range of the original problem? Bam. You're on it today, both you girls. Find the domain of the inverse, which is x cannot be equal to 2, and that's got to match the range of the original, so this is y cannot be equal to 2. Good. Okay, that's it. Okay, everybody good? All right, put everything down for one more second. We still have about 30 minutes, so we're in great shape.